Hello everyone, welcome back to my YouTube channel CSN IT Tutorials by Vrushali. In our previous session, we have discussed about complete introduction of data science and big data. I have attached link of that video in below description box. Now, in today's session, we will discuss the next important topic, that is mathematical foundation of big data. This video will be helpful for your university exam point of view plus interview purpose. Let's start the session. So previously we have already discussed all the subjects in detail with practical demonstrations, solve examples and real life applications. I have attached link of all this playlist in below description box. Please share my channel with your friends and subscribe it. That will be beneficial for everyone. Now, in today's session, we will discuss all this topic. These are the mathematical foundation, base of data science and big data, which include conditional probability, Bayes theorem, then Markov chain algorithm, random walk, pairwise independence, universal hashing, then Martin algorithm, distance sampling, random projections, Bloom filter, and at the end, mode, variance, standard deviations. So we will discuss all these algorithms with solve examples. At the end, we will discuss important question bank on this particular topic. Now, let's see all these points one by one. Now, the first question is what exactly conditional probability? See, probability is one of the base or foundation of mathematics. In machine learning, data science, deep learning, big data, AI, everywhere, probability is a base of everything. So what exactly conditional probability? Assume that there are total two events. One event is already happened and another event will get to happen. So to calculate probability of this scenario, we are using conditional probability. So there is a one specific formula. See, we are reading this like probability of A given that B means B event is already happened and A event will happen, right? So there are total two events and the formula is probability of A intersection B divided by probability of B. This is the formula. Now let's understand this formula with example. See here, assume that in particular class there are total 60 students. 40 students like mathematical subject and 25 students like maths plus science subject. And now you have to find out the probability of student who like science given that they like maths. You have to calculate probability of this thing. So how to calculate? Simple one. So first there are total two event. One event A to like science, B event like mathematics. Now, just mention the formula of conditional probability, right? Now see here. Formula is probability of A intersection B. So intersection means common student who are like both maths and science. So common students, that is 25. So A intersection B is 25 divided by probability of B. So B means who like mathematics and the value is 40. So 25 divided by 40 and answer is 5 by 8. So that much probability is a particular student like science given that they like maths. So this is called as conditional probability. Now let's understand Bayes theorem. See, conditional probability is a base of Bayes theorem. It is a base of mathematical foundation. So see here first the formula of Bayes theorem. See, probability of A given that B is equal to probability of B given that A means A event is already happened, find out B into probability of A divided by probability of B. So this is a Bayes theorem formula. So first we will understand where Bayes theorem is exactly used. So these are the some applications. Let's take an example of medical diagnosis. See, Bayes theorem generally used where you have to find out or predict the result as per the previous evidence. At that time, Bayes' theorem have used. In medical diagnosis, if you want to find out the probability of disease as per the symptoms, so for finding this thing, Bayes' theorem is used. Like in spam detection, there are some spam emails are there. If you want to find out the probability of spam email as per the keywords, some emails included the words like offers, discount, 50% offers. So these words are included in spam emails. So you have to find out the probability of this email as per the keyword, right? So everywhere to find out the prediction, probability as per the previous evidence. This is called as Bayes theorem. Now let's understand with example. So see here, solve example of Bayes theorem. This is your given data. First thing, 1% of people have disease. So we are considering that probability of A is 0.01, that is 1%. And probability of A means a particular person having disease. Got it? Second thing is, test is 95% accurate if person has disease. So 95% accurate means positive test, and if person has disease means this A, right? So we are mentioning probability of positive given that A, that is 0.95%. Next one is test give false positive result. False positive means a particular person doesn't have any disease. Still, your machine shows a result positive, which is called as false positive result. So test give false positive result 5% of time. So we are mentioning probability of positive result for A dash. A dash means a person doesn't have any disease, and A means person carry a particular disease. Got it? So the probability of this one is 0.05%. So this data is given. Now you need to find out probability of A given that positive means probability of person who actually has disease and their test is also positive. You have to find out this thing. So let's see here. Step 1, you have to write down the Bayes formula. See, this is your Bayes formula that we have already discussed in last slide. So we are mentioning in this way as per our given statement, like probability of A given that positive, that we need to find out, right? And mentioning positive given that A into P of A divided by P of positive, right? So same formula is this. Now step 2 is you have to find out P of positive. See, positive given that A, this value is already there. P of A, this value is also there. So you have to find out first P of positive. So first just arrange this formula as per the mathematical rule. See, you have to find out P of positive. So there are total two cases. Either a test is positive and person also having disease, or test is positive, a person didn't having any disease. This is a true positive plus false positive. Okay. In this way, you need to arrange this thing. Now tell me, probability of positive given that A. What is the value of this? 0.95 into probability of A is 0.01 plus probability of positive given that A dash means a person test is positive but there is no any disease. That is false positive result 0.05 into probability of A dash. See, probability of A is 0.01. So 1 minus 9 simply that is 0.99. A person doesn't have any disease and this is person having disease. Got it? And just solve this thing and final answer is 0.059. So this is a value of probability of positive. Okay. A particular person when they test it, so their result get positive, that is 59% is there, right? Now next, so step 3 is you have to apply this formula, same formula, right? So we have to first calculate this value, probability of positive. So just put up the value, like positive, given that A is 0.95, probability of A is 0.01, divided by, we are calculating probability of positive on previous slide, that is 0.059, and their calculation final answer is 0.161. So in step 4 you have to write down the final answer, that is a person having a disease and also their test is positive. So this probability is 0.16, that is 16%. Got it? So in this way you need to calculate Bayes theorem. A particular event is already occurred, or by using some evidence you can calculate the future data. So that can be used in future prediction purpose or decision making purpose. Got it? So this is called as Bayes theorem. So see here. So even test is positive, actual probability of disease is only 16%. Next topic is Markov chain algorithm. So name suggests that chain. Chain means one state is depend on another state. So Markov chain is one kind of mathematical model or state model that can be used to find out your system state. They describe your system state from move from one to another state. So the rule is your future state is depend only on present state, not the past tense. This is the rule of Markov chain algorithm. So let's understand with the example. See here, suppose there are total two states. S1 is sunny and S2 is rainy. Only two states are there. So, as per the Markov chain algorithm, they create the chain or they find out the chain or states of particular system. How? See, assume that if today is sunny, so tomorrow is also sunny. So their probability is 0.8% or 80%. On the opposite of that, if today is sunny, tomorrow is rainy season, right? So the probability is 0.2, that is 20%. So these are the assumptions. Again, in another way, if today is rainy, tomorrow is sunny, the probability is 0.4, or if today is rainy, tomorrow is also rainy, the probability is 0.6. So this is called as assumptions. You need to find out a particular state from one to another, right? So for that purpose, in Markov chain algorithm, they use transition probability matrix concept. See, sum of each row equal to 1. See, in this particular two state, 0.8 plus 0.2, that is 100%, right? Again, in this state, 0.4 plus 0.6, again 100%, right? So sum of each row is equal to 1. They properly divide the two states. Got it? Now, see, Markov chain algorithm use the concept of transition probability matrix. See here, this is a transition probability matrix. See, first 0.8 and second one is 0.2 for sunny weather. So you have to mention in this way 0.8, 0.2. So this row mention the current state, right? And column mention the next state. And every row their calculation or sum is equal to 1. Now second row mention for rainy season 0.4 and 0.6. So this is called as transition probability matrix. Now, now understand first where this Markov chain algorithm is rarely used in our daily life. One of the most important example is Google page ranking algorithm, that is page rank algorithm. See, multiple user visit a particular website, right? When they click on particular website, then they move to the again next page, right? Again they move to the next page. So next page is depend on previous page, right? Because there are multiple hyperlinks are there. You just go to forward and backward as per the particular website, right? So this is the best example of Markov chain application. Another example is stock market analysis. See, share market value is depend on current state of market, right? and share market values are continuously changing. Within second, their values are changing. So for share market analysis, stock market prediction purpose, Markov chain algorithm have used. Again, in weather prediction purpose, customer behavior like a market basket analysis algorithm, then machine learning, speech recognition system, and also for genetic purpose. These are the main reasons where Markov chain algorithms have used. They find out the state of each and every system or machine. Now, let's understand solve example of Markov chain algorithm. This example have asked in your previous year question paper. See here. Suppose your given data is a particular person, their last purchase was Coke. Okay. After that, there was a 90% chance his next purchase will be Coke. Means a particular person first buy Coke and 90% chance in second purchase also they buy Coke. Okay. Means first Coke and second also Coke. Now third statement is if particular person last purchase was Pepsi, then 80% chance their next purchase will be Pepsi. So this is your second statement. Now you have to find out, see, person is currently a Pepsi, then what is the probability he will purchase Coke to purchase from now? Means first they purchase Pepsi. In between that, again they purchase some another thing, and after to purchase, they again purchase Coke. Means you have to find out the probability of this thing. See, now you will understood this thing. There are particular change, particular states in this given question, right? Now let's see how to solve this. So first thing, you have to mention a particular variables like Coke means C and Pepsi means P, right? Now second step, as per your given data, step 1, define states. See, as per your given data, 90% chance first they purchase Coke and after that again they purchase Coke. So probability of C to C. Okay, this is a chain. First purchase Coke, again purchase Coke, right? So C to C chances is 90%. 90% that is 0.9. Next given data is a person purchase Pepsi, again they next purchase Pepsi. Means probability of Pepsi, again they purchase Pepsi, that is P2P 0.8, that is 80%, right? Now see here, your total probability is equal to 1. So this is your given data. Now you have to again find out the remaining or false positive value for put up this value in formula. Okay, see here. First they purchase Coke, then again they purchase Coke, that is 0.9. If particular person first purchase Coke, then purchase Pepsi, means 1 minus 0.9. 0.9 value is already there. So just 1 minus 0.9, 0.1. Means 10% chances is there first Coke, then Pepsi. And 90% chances is there first Coke, again Coke. Got it? Similarly here, if a particular person buy Pepsi, then they again buy Pepsi, that is 80% chances as per our given data. And if particular person buy Pepsi, then they again Coke, that is 1 minus 0.8, means remaining one is 20%. Got it? So this is your first state. You have to define the states as per Markov chain algorithm. Now step 1 is to define the states. Okay, this is a answer of your step 1. Now step 2 is calculate transition probability matrix. So see here, this is your transition probability matrix as per the step 1. See, 0.9 Coke to Coke and 0.1 Coke to Pepsi. Then second row, 0.2 is Pepsi to Coke and 0.8 is Pepsi to Pepsi. Now check the value of sum of row is equal to 1, right? So row means current state and column means next state in Markov chain algorithm, right? So as per your step 1, you have to generate transition probability matrix. Now see, You have to find out, as per your problem statement, a particular person currently a Pepsi purchaser and probability that he will purchase Coke to purchase from now. Okay, to purchase from now. So when this kind of data is mentioned, write down this formula. To purchase means P square. Okay, that is probability of square. And currently Pepsi, that is first P. And after to purchase Coke means P to C. Got it? If in your exam they will ask 3 purchase from now. So at the time of 2 you have to mention 3. Got it? So this equation we will generate from this given data. Now see. Now you have to elaborate this formula as per our mathematical rule. See. So this is a 2-1 which is called two-step transition formula, right? See, this is our given formula. Now you have to elaborate those formula in a particular way. See, so first one is a single P is there, okay? P to C and again C means a particular person buy Pepsi, then they buy Coke, and after that they buy Coke. Like two purchase from now. Okay, this is your first purchase. This is another purchase, and after two purchase they will buy Coke. Got it? This is your first statement. Plus, if particular person buy Pepsi, in middle they buy Pepsi, and after that they buy Coke. This is your second statement, right? Assume that. This is the assumptions. In our given data, first Pepsi and last Coke is mentioned. First Pepsi and last Coke. So in between that, either they buy Coke or Pepsi, right? So in this way you have to elaborate those formula. Now just put up the value. See, our first path 1, take this one. Okay, this is your first path 1 plus path 2. In path 1, just put up the value. See, first one is P to C. So P to C value as per our step 1, that is 0.2, 0.2 into P2 again C, that is Pepsi to Coke. Okay, this पहले transitivity like this, P to C and P to C again, C to C again. Okay, so there C to C is 0.9. So 0.2 into 0.9, answer is 0.18. Similarly, your second path, this one. Okay, so just elaborate this one. First, probability of P to P into probability of P to C. So P to P probability answer is 0.8 and P to C probability answer is 0.2. Okay. So path 1 0.18 and path 2 0.16. So make a addition of it and answer is 0.34. Means 34% probability is there. A particular person currently purchase Pepsi and after to purchase again they buy Coke. Got it? In this way, similar way, you need to solve this example in your exam. So this question generally asked for 7 to 8 marks. So just practice it. Now, the next topic is random walk. Random walk is one of the type of Markov chain algorithm model. This is one kind of model. This model again indicate step-by-step transition, or they find out the future step or previous step. So this random walk algorithm majorly used in stock market price modeling. In stock market, your next value is depend on previous value, or all share values are depend on current state of market, right? So random walk means randomly values have generated sometimes. So this is a best example of stock market price modeling where values are continuously changing, right? Again, in different searching algorithms, page ranking algorithms, where random walk this model have used. Now let's understand with example. See, assume that suppose a particular person, this person stand at position 0 at number line, right? So there are only two types of probability. Either a particular person move to right side or they move to left side, right? Only two probability are there. So this thing is called as neighbor state, right? So Suppose the particular person move to right side. So move plus 1 right. And probability is 50%, that is 0.5, right? And suppose a particular person move to left side, that is move minus 1 position. So their probability is 50%. Got it? So 50% probability is right side, 50% probability is left side. In neighbor state, in current state. This is called as random walk. In another example, suppose a particular position stand out at 2 position at number line. So the next position will be either it is 3, that is forward position, future state, or that is a previous one, past state. So 2 plus 1 3 or 2 minus 1 1. So 50% probability is there. So this is called as random walk. So sometimes your OTP. So OTP is your randomly generated, right? Every user get the random OTP, right? Again in searching algorithms, you can search multiple keywords on Google, right? Suppose you are searching university, this particular keyword. So while searching in branch prediction, they were giving the suggestions like University Pune, University Mumbai, means present state and future state. They are displaying this keyword, right? Suppose you are searching only data. So they are giving the suggestion either it is big data, okay, or small data in this way. So as per your keyword, they are giving you future suggestion, future keyword, next keyword, or previous keyword. So this is called as random walk model. So this model generally used in prediction purpose or assumptions evidence purpose. Got it? Now next topic is pairwise independence. As we discussed earlier, in big data, there are billions of data have generated within second, right? Every from social medias, banking applications, then gaming applications, different websites, everywhere data is there. Some data in structured format, some data in unstructured format. So there are multiple pairwise data is there, right? So pairwise independence. This name suggests that every event, every pair or every keyword work independently, differently, right? How? See here. Let's take an example. Suppose there are total 3 events, event A, B and C. So assume that probability of A intersection B. So in this event, 2 events are there like probability A, probability B. Suppose next calculation is A intersect with C, means 2 events again, probability of A, probability of C. Next one intersection of B and C. So again 2 events are there, probability B and probability C. So all these pairs, all these events are separate, independent, right? And as per that particular data, you can't mention any assumptions, right? You can't mention this thing, right? Probability of A intersect B intersect C. You can't mention this thing, right? Because every pair work independently. You can't do any assumptions as per the particular data. So this is called as pair-wise independence. This pair is different, so which is not equal to probability of A, probability of B, probability of C. This pair is different. So every pair, every variable, every event work independently or differently. This is called as pair-wise independence. In your exam, they will ask, write a short note on pair-wise independence. So here again you have to mention this example C. Assume that there are total 2 coins. First coin, or when you are tossed the coin, first coin is head and second coin also get head. Means 2 heads are there. That is even number of heads, right? So both coins are work independently. There is a pairwise independence, not a mutual independence. Got it? So this is called as pairwise independence algorithm. So this algorithm majorly used in hashing techniques, because in hashing we are using multiple hash functions. So every hash functions generate different types of data. Every hash functions work independently, right? Again in randomized algorithm, streaming algorithm. Nowadays lots of streaming data is there, like live cricket matches, online web series streaming is there, right? On YouTube, Amazon or Netflix. So streaming algorithm, they pairwise independently work. Means every data is streamed batches wise, bulk wise, right? And due to some network issue or any other outages, a particular batch is loaded and other batch is not loaded, right? But this is a pairwise independence. Every pair, every batch work independently, separately. Again, it can be used in approximate counting in mathematical model, right? So this is a concept of pairwise independence. Now, the next topic is Flajolet Martin algorithm, which is also called as FM algorithm. As we discussed earlier, nowadays millions or billions of data have generated, and to store all this data in database it is not possible because they require a huge memory and that will get very expensive, right? So for that purpose Martin algorithm have used. It is one of the probabilistic algorithm. This algorithm used to find or estimate number of distinct or unique elements in your data. For that purpose, they are using very little memory. So basically, FM algorithm find out distinct elements in your data. Let's understand with examples. See, on daily basis, number of unique website visitors have generated, right? Again, in particular network, unique IP addresses have connected. On daily basis, unique search queries have generated. For example, a particular person want to search information about big data. So they are searching information of big data. Another person searching application of big data. Another person just searching big data, right? So every user search query is different and unique is there. So to handling all these things, Martin algorithm have there because they stored only unique data, distinct elements in your database. Now understand with solve examples. So before solving example, first we will understand concept of Martin algorithm. As per your exam point of view, this is one of the most important question. So let's see here. First we will understand through the example. Assume that you have a one coin, right? So first time you will toss the coin and you will get the tail, right? Only one time. This is a common. Now assume that you are tossing same coin 5 times and 5 times also you will get the tail. So this is a rare one. This is not a common, right? So at that time Martin algorithm have used. They find out a unique element, distinct element in your data. See here. So this algorithm used concept of trailing zero. So trailing zero basically means, see here. This is a particular binary number in 0101 format. So trailing 0 always calculated from the right side, okay, from the end of this thing. So in this particular binary data, how many trailing zeros? 1, 2 and 3. 3 trailing zeros, right? Again another example, suppose 110. Calculate from the right side, okay? How many trailing 0? 1. In this example, 1011. There is no 0 on right side. So how many trailing zeros? 0. So this is a concept of trailing zeros. Trailing zeros always calculated from the right side. Now, as per big data rule, suppose in your data set, one trailing zero means it indicate your data set is very small. Suppose as per the data, 3 trailing zeros are there in particular elements in particular data. So they indicate the medium data set. But suppose more than 10 trailing zeros are there which indicate very large data set. This is the rule of big data because every data has stored in binary format which is understandable by the machine in 0101 format, right? So that's why this trailing zeros concept are there. As per the trailing zero, they indicate the size of data set. Now next thing, This is a probability concept of trailing 0 as per the big data rule. Suppose probability of one trailing 0 is 1 by 2, that is almost 50%, right? Means 50% chances is there, only one trailing 0 is there. That is a unique elements. Probability of 2 trailing 0, 1 by 4. Probability of 3 trailing 0, 1 by 8. And in this way you can calculate probability of any r trailing zeros. And the formula is 2 to the power r. So r means how many zeros, how many distinct elements have generated in your algorithm. Again, let's understand with one small example first. See, so R indicate number of distinct element must be large. Okay. See, there are two distinct elements. There are 4, there are 8 and there are R number of distinct elements. See here. Suppose there is an example, this one. So how many trailing zeros are there? Calculate from the right side. 1, 2, 3, 4 and 5. So total 5 trailing zeros. So just apply this formula. So distinct elements can be calculated by 2 to the power r. R means trailing 0. So 2 to the power 5 and answer is 32. Means 32 distinct unique elements present in your data set. So this is the concept of Martin algorithm. Now let's understand Martin algorithm with solve example. So this example asked in your previous year question paper. Almost 2 to 3 times same example have asked. This question will be for 7 to 8 marks. Now see here. Your given data is first a particular stream is given. So this is your given data. Okay, sequence of data. Second, hash function is given. Okay, so there are only two given. First, streaming of data and second, hash function. And your hash function is 6x1 plus 1 mod 5. This is your hash function. Now you have to find out the distinct element, unique elements from this particular data. Now see here, before calculation, how many unique data are there? 4. Like 1, 2, 3 and 4. And other data is just repeatedly present, right? This thing you need to find out by using Martin algorithm. So this is just a small data set. But assume that you have a millions of data, billions of data is there. So to calculate this thing manually, it is much difficult, right? And also expensive. So for that purpose, Martin algorithm have used. So let's see how to solve this example step by step. So step 1, you have to apply hash function on unique elements. So there is 1, 2, 3 and 4. So in your exam, they can give any stream, any data is there. So you have to calculate the apply this hash function on every element only once, right? See. So our first value is 1. So apply hash function on it. Our hash function is h of x, x means 1 now, 6 into 1 plus 1 mod 5. So 6 into 1 7, 7 plus 1 8, 8 mod 5. Mod means reminder, right? So after dividing 5 to 8, reminder is 2. So here you have to mention the binary value of 2. So binary value of 2 is 0, 1, 0. So minimum 3 binary data is sufficient. That is a secured one, right? Now after that you have to calculate the trailing 0. How many trailing zeros are there? Only one. Trailing zeros always calculated from the right side. Trailing 0 is 1. Similarly, next element is 2. So again put up this 2 value in hash function. H of 2 equal to 6 into 2 plus 1 mod 5. So 6 into 2 12, 12 plus 1 that is 13 mod 5 and a reminder is 3. Now again write down binary of 3 that is 0, 1, 1. So calculate the trailing 0. There is no 0 on right side. So trailing 0 is 0. Again next value is 3. So put up 3 value in hash function like h of 3 equal to 6 into 3 plus 1 mod 5. So 6 into 3, 18 plus 1 mod 5, that is 19 mod 5, and remainder is 4. So just write down binary of 4, 1, 0, 0. And now trailing 0 is 2, 1, 2. Again, next one is 4. So put up this value in your hash function, like 6 into 4 plus 1 mod 5. So 6 into 4, 24 plus 1, that is 25. 25 mod 5 equal to 0. Always remember this thing. If your mod answer is 0, hash value, just discard it. Hash value 0 is not possible, right? So you have to just remove this particular equation. So the trailing zeros are 0 here, okay, because hash value is 0. Now second step is you have to find out maximum trailing 0. See, here trailing 0 1, here 0, here 2, and again here is 0. So which one is maximum one? Maximum one is 2, right? So apply distinct element formula. See, step 3, find distinct element, that is 2 to the power r, and upper r value, that is trailing 0 value, is 2. So 2 to the power 2, and answer is 4. Means in your data set, 4 distinct elements are there. See, 1, 2, 3, 4. These are the distinct elements. But sometimes while solving example, actual and distinct elements sometimes may be different, right? So this is the approximate answer of Martin algorithm. In this way, they find distinct and unique elements. Now, in your exam, you can also solve this question in similar way. Just practice it 2 to 3 times, which is very easy to solve for 7 to 8 marks. So first step is apply hash function on unique values. Second step, find maximum trailing 0. Third step, find distinct element by using 2 to the power r, and you will get your distinct element. So this is called as Martin algorithm. Now the next topic is distance sampling. So distance sampling, this one of the probabilistic technique. This technique used in Martin algorithm to find out the unique elements. See, nowadays in big data, lots of data have generated by using different sources or streams. Sources included any social applications like Insta, Facebook, then WhatsApp, then again any reservation application, banking applications, or any other application where all these applications are supporting to generate multiple data, to generate massive data, and to handle all this massive data accurately, efficiently, in low memory and high speed. For that purpose, distance sampling techniques have used. So there is a simple basic formula that we discuss on Martin algorithm, that is to find out the trailing zeros, 2 to the power r. This thing is called as distance sampling. So this particular methods have used in multiple advanced database like Apache Spark, Apache Cassandra, Apache Hadoop. They are using this method to find out the distinct and unique elements. So these are some examples like to counting unique website visitors, then network traffic monitoring, like how many unique IP addresses have connected in computer network, or any fraud risk analysis purpose, in again cyber security for hacking purpose, then database optimization. So for everywhere, this method have used to find out unique or distinct elements in your data. So these are the simple steps that we have already solved example on previous slide. Like instead of storing all the elements, you can apply hash function, convert it into the binary number, and counting number of trailing zeros. And after that apply this formula. They give you a unique elements. So again, there are multiple advanced algorithms in AI, deep learning, data science. So these algorithms are merging with this distance sampling to find out all the unique data from wide one. Now, next topic is random projection. This is one of the most important topic for your exam point of view, like write a short note on random projection. So basically, random projection used in big data to convert your high dimensional data into the lower dimensional format, or we can say approximately preserving distance data. So random projection mostly used in machine learning in clustering techniques, or also it can be used in compression purpose. If you want to compress your data, compress your image into the some large size to small size without removing the data. For that purpose, random projection model have used. This is one kind of compression techniques, right? Again, it can be used in recommendation system, then in a k-means or nearest neighbor algorithm in machine learning, they use random projection. Now let's understand with the example. See here, assume that there is a one two-dimensional point, and this two-dimensional point is 3 and 4. We are considering 3 means x-axis and 4 means y. So this is a two-dimensional point. Now you need to convert this two-dimensional point into the one-dimensional format. At that time, random projection model have used. They convert your dimension or compress the data. Let's see here. See, suppose at that time they take some random direction, which is called as random data or random vectors, and assume that these random vectors are 0 0.6 and 0 0.8, right? Now apply the random projection formula. See, first is the x-axis, that is 3 into 0 0.6. This is your x random vector, and plus 4 into 0 0.8, right? And after solving this, you will get the one value, that is 5. And 5 is your one dimensional value. Means a particular data, when it is two dimensional format, it can be mentioned as 3, 4. And when you convert this data from two dimensional to one dimensional format, it can be represented by the 5, one single digit. So this is called as random projection. They are considering some random vector points are there and used in conversion of dimensional conversion purpose or compression purpose. So this is a simple concept used in big data. Now let's understand basic difference between distance sampling and random projection. See here, distance sampling find out distinct unique elements in your data, and random projection is used for reduction of dimensionality or data compression purpose. Distance sampling based on hashing technique and trailing zeros are there, and random projection use some random vectors or random linear transformation algorithms. So distance sampling again used in streaming algorithm purpose, like batch wise streamings are there in particular app, and random projection algorithm used in machine learning, in nearest neighbor algorithm, in clustering purpose. So distance sampling technique used in FM algorithm, like Martin algorithm that we have discussed previously, and random projection algorithm is based on JL lemma algorithm for projection purpose. So this is the basic difference between this. Now next and most important topic is Bloom filter. As per your exam point of view, again this one is important. So as we discussed earlier, there is massive amount of data have generated on daily basis in big data. So Bloom filter is space efficient probabilistic data structure algorithm. If you want to find out a particular element is present in your dataset or not, so for this purpose you are using Bloom filter algorithm. Bloom filter algorithm gives output only for in three ways. First, either your element definitely not present in the particular dataset. Second, your searching element is possibly present in your dataset. And third way, it may give false positive result sometimes. So false positive result means a particular element is not present in your dataset. Still, due to some outages, they are giving the notification a particular element is present. So this is called as Bloom filter. Bloom filter never give false negative result. So basically this model is just used for membership checking purpose. So membership checking basically means you have to check that a particular element is present in dataset or not present. So this kind of concept generally used in database management system. So we are using primary key indexing, this kind of functions. Then a web caching purpose, you can search multiple keywords on Google, right? Suppose you are searching college, this kind of keyword. So Google can display all the websites, all the PDF or videos where college keyword is exist, right? Again in distributed system, in Apache Hadoop system, this Bloom filter have used. Now, structure of Bloom filter. See here in this particular image. First is Bloom filter consists the array, that is bit array in 0101 format, right? And initially all array mentioned as 0. Second, there is one any independent hash function. Okay. So only two things are there. First one is array, second one is a hash function. Now let's understand Bloom filter with solve example. See here. This kind of example have asked in your previous year question paper. So let's solve it. See, our given data. First bit array size is 10, means your array size, that is 10, means from 0 to 9. So initially your array all are 0. Number of hash function 2, means you have to apply 2 hash function on it. Again hash functions are given. First hash function x mod 10 and second hash function 2x plus 3 mod 10. So we already discussed hashing concept, hash functions in detail in our previous lectures. In database, in data structure, we have already learned this concept, right? So hashing concept generally is used for security purpose basically, right? So this data is given, hash functions are given and you have to perform this operation. First, you have to insert element 7 in this array. After that 4. Then you have to check 6 is present in this dataset or 14 is present in dataset or not. Got it? This is your given data. Array size, initial array, 2 hash function and you have to perform this operation. Now let's see how to solve this step by step. So our step 1 is you have to insert element 7, right? So mention or put 7 value in this hash function or both hash function. So first h1 of 7. 7 mod 10. You can't divide 10 for 7, right? So reminder is 7. 2 into 7 plus 3 mod 10. So answer is again 7. This is a reminder value. So first hash function answer is 7 and second hash function again answer is 7. Now you have to set index 7 to 1. Okay. See, answer of both hash function is 7. So mention 7 in this particular array as 1. Okay, this is a zeroth index, first, second, third, fourth index wise. Bloom filter always works index wise, right? So this is 0 and on 7th index you have to mention 1. So this 1 indicate that 7 element present in this particular data set. Now next you have to insert 4. Same. Put up 4 value in this hash function one by one. So 4 mod 10, reminder is 4. Then 2 into 4 plus 3, that is 4 into 2 8 plus 3 11 mod 10. So reminder is 1. Now first hash function generate 4 value, second hash function generate 1 value. Now you have to set index 1 to 4th position and first position. See 0 1, there is a 1 and at again 4th index again 1, right? This is the array, start from the 0, right? So in this way you can insert the elements. Now next one is you have to check that element 6 is present in this data set or not. See, check element 6. So put 6 value in this hash function. So 6 mod 10, 6. 2 into 6 plus 3 mod 10. Answer is 5. So check that on 5th and 6th position 1 is present or not. Now check here on 5th position 0, 1, 2, 3, 4 and 5. There is no 1 is present. Means 6 is not present in your data set. Okay. Again check with the 6th position. So 6th position also is 0, right? So 5th and 6th both positions are 0. Means 6 element definitely not present in your data set. 1 means present, 0 means not present. Now again check element 14. Now look at here carefully. So put up this 14 value in this hash function. 14 mod 10. Reminder is 4. 2 into 14 plus 3 mod 10. Again reminder is 1. So you have to check that 14 element is present at 4th index or 1st index. Check here in this data set. First index is 1, right? And 0, 1, 2, 3, 4. Fourth index is also 1. Okay. But see here on 4th and 1. So both positions are already 1. Why? Because we are storing 4th element 4 is there. See at 4th position and 1 position we are storing element 4. But this Bloom filter showing that 14 is present at 4th and 1st position because 1 is there, right? So this is an example of false positive, right? False positive means system gives that a particular 14 value present in dataset but actually didn't present it. This is called positive value. So Bloom filter says possibly present here. So this is a solve example of Bloom filter. In your exam also you can solve in this way step by step. This is the simplest one. Just practice it. Solve any two examples accordingly. So first step, insert element, put a value in hash function, calculate their mod value and set index value accordingly. Similarly one by one stepwise you have to solve this. Now next one is the simplest topic that we have already learned in mathematics. Big data is a base of mathematical model. So where you can learn mean, mode, then variance, standard deviation, this kind of functionalities, right? So let's understand what exactly mode. So mode basically means value that appears most frequently in dataset. Let's understand with example. See. First take an example of unimodel like data is given 245 4647. Now tell me which element is maximum time present in this data set. That is 4, right? 4 appears 3 times here. So mode of this particular data is 4. Like which element maximum time present in your data set. Again take a second example. See here. Now tell me which elements are majorly present in your data set. 3 present 2 times. 5 again present 2 times. 7 and 8 present 1 times. So here mode is 3 and 5. Both elements are equally present in your data set. So this is called as mode. So in your exam a particular question is given like data is given and you have to find out mode, variance, standard deviation for 6 to 7 marks. So remember this thing, mode means value that appear most frequently, majorly in dataset. Now the next topic is variance. I think you have already learned variance in mathematical subject. So variance tell us how much different values have generated near to average value. Suppose a particular data value is near to the mean value which is called as small spread variance. And if particular data value far away from the mean value which is called as large spread data set. So here this is a basic formula of variance. Here x means your data value Then this one is means mean, and n means total values. So this is the formula of variance. Now let's understand with the example. So a particular data is given like 2, 4 and 6, and you have to find out the variance. So first step 1 is you have to find out the mean value. So the formula of mean is total values like 2 plus 4 plus 6 divided by total values. So total values are 3. So mean of this particular data is 4. Okay, this is your first step. Now in second step you have to find out the deviations. So deviations means, see, here you have to make one table, that is value x minus mean and x minus mean square. So just put up this value, see 2 x minus mean. So x means your data value, like mean value. So mean value is 4, right? So 4 minus 2. 4 minus 2 is minus 2. Next 4 minus 4 is 0. 4 minus 6, that is 2, right? Next you have to calculate x minus mean square. So minus 2 square is 4. 0 square is 0 and 2 square is 4. So deviation formula is sum of squares. So sum of squares like 4 plus 4 equal to 8. This is your deviation. Now in step 3 you have to find out the variance by putting all values in this formula. So x value means your mean value, x value means your data value like total data value, that is your mean value 4, and n means your total values are 3. So 8 by 3, and answer will be 2.67. This is the variance of your data set. So just remember all this formula. This is one of the easiest question that repeatedly asked in your paper. Now next one is standard deviation. So standard deviation basically means square root of variance. It can also used in big data to find out the deviations of in data, right? So it measured the spread in same unit of data as variance. See here, the formula is root of variance. So as per our previous example, variance is 2.67. So what is the standard deviation? Root of 2.67, and answer will be 1.63. So just practice this mode, variance and standard deviations. Now, as per your previous exam question papers, one of the most important question, explain Bloom filter along with application and derive the equation for probability distribution in Bloom filter. So you have to explain this concept with example for 7 marks. Next question is this, that we have already solved in our previous slide, like this one, bias theorem question. uh, True positive, false positive values are given and you have to find out the probability for 7 marks. So this data is already given. So try to solve this example. We have already solved on previous slide. Next one is explain the following term like distance sampling and pairwise independence for 6 marks. Then see, data set is given and you have to find out variance and standard deviations for 7 marks. Next question is related to the Martin algorithm, like explain Martin algorithm and find out the unique elements in this particular data, and hash functions are given. So we have already solved this kind of examples. Now try to solve this one. See, we have solved this example in our slide for 8 marks. Similarly, this example also asked in your previous year question paper. Now this one again, next example, like a Markov chain algorithm, like related to the Coke and Pepsi, that again we have solved on previous slide. So just practice it. So this is all about of your second unit. Practice it. All the best and thank you. And please share my channel with your friends and subscribe it. Thank you so much.